Hello, my name is Areeyapath Kalawa. For today, I would like to present the research article entitled Rapid and Effective Removal of Heavy Metal Ions from Aqueous Solution Using Nanostructures Clay Particles. Heavy metals contamination in water is a serious problem. Toxic metals such as cadmium, lead, nickel, and chromium are commonly released from industrial and agricultural activities. These metals are dangerous because they are toxic to humans, aquatic organisms, and remain in the environment for long times. Several techniques have been developed for heavy metal ions removal. However, many of them are expensive, use a lot of energy, and sometimes cannot remove heavy metal ions completely. Therefore, a development of low-cost, effective, and environmentally friendly removal methods is highly desirable. Clay is a hydrous aluminosilicate material composed of silica tetrahedral layers and alumina octahedral layers with interlayer waters and exchangeable cations. Clay is a low-cost and abundant material. It has high surface area and high cation exchange capacities and environmentally friendly properties. Because of these advantages, clay is a good absorbent for heavy metal ions removal. In these studies, several analytical techniques were used to characterize the clay samples. XRDs for mineralogical and crystal structure identifications, FESEMs for observing particles morphologies and size, bed analysis is for surface area and pore volume determinations, ICP-MS for element composition analysis, and AS for measuring metal ions concentrations. The main objectives of these studies include, first, to evaluate natural clays as an absorbent for PB2 removal from aqueous solutions. Second, to characterize clay properties and its absorbance and its absorption properties. And third, to study the effects of pH, absorbent dosage, and PB2 concentrations, and to analyze the absorption mechanism and kinetics. The experiments consist of 3 parts: clay samples preparations, material characterizations, bed absorption experiment. First, clay samples from Shakalahan mine, Iran, was treated with acids and dried, and then 1 gram of clay was added to 100 ppb of PB2 solutions. After absorptions, the remaining PB concentrations was analyzed using AS. Next is the result and discussion parts. For clay characterizations, samples M1 to M4 were used. ICP-MS analysis confirmed that the clay samples contained metal oxides, which act as active sites for PB2 absorptions, and silicon dioxide was the dominant component in all samples. The figure on the left shows XRD patterns, which verify the crystalline phases of clay minerals, and the images on the right shows FESEM micrographs, revealing nano-sized clay particles with M1 and M4 having the smallest particle size. For these tables, bed analysis showed that M1 and M4 exhibited higher specific surface area and pore volumes compared to M2 and M3. The left graphs show that sample M1 and M4 achieved removal efficiencies greater than 90%, and M1 and M4 were selected for further studies. The right graphs show that the removal efficiencies increased as the pH increased from 3 to 7, indicating that natural pH is optimal for PB2 absorption. Next, the left graphs show that increasing absorbance dosage enhance removal efficiencies due to the availabilities of more adsorption sites, and 1 gram per 100 milliliter was the optimal adsorbent amount. And the right graphs show that higher PB concentrations reduce removal efficiencies because of adsorption site saturations, and 100 ppb was the optimal PB concentration. The two graphs on the left shows that the adsorption data fitted the linear isotope model better than Fehrenheit isotope models, as indicated by the higher R-square value, confirming monolayer adsorption behavior. And the two graphs on the right shows that absorption process follow pseudo first order kinetics, as experimental data shows the best agreement with the model predictions, and the adsorption equilibrium reaches within 120 minutes. In conclusions, natural clays are low cost and effective adsorbent for PB2 removal from aqueous solutions. Under optimal conditions, the removal efficiency is greater than 90%, and adsorption followed the linear isotherm and pseudo first order kinetics, indicating monolayer adsorptions on the clay surface. Therefore, natural clays show strong potential for wastewater treatment applications. Thank you.